Hello everyone, welcome back to my YouTube channel. In the previous video, we have started with the slicing concept in Python arrays. I hope you have understood that concept. So here is the recap of what we have studied in the previous video. We have seen the concept of slicing in Python arrays with a simple example of cube. I hope through this example you have understood the concept of slicing. Next, we have seen the detailed syntax of a normal slicing in Python arrays. We also have seen certain key points that we have to keep in mind while slicing the arrays. We have seen that the start index is inclusive and the end index is exclusive. After that, we have seen the implementation of this. We have seen ample amount of examples, and I'm sure that after watching this you have got this. Next, we also have seen the negative indexing, the significance of negative indexing, and then we have seen some examples on that. I hope that this were useful. Now it's time to move on to another concept in slicing, which will take you a step ahead for understanding the concept in detail. So it's time to start with the concept of step size in slicing. So let's have a look what actually the step size is. So basically, step is the third argument that you have to give while slicing the arrays. Note that this step argument is an optional argument. It's totally up to you that whether you need this or not. If you need this, then you need to mention it after the stop index. Next, it determines the increment between each index while slicing. So the normal slicing will take a subset from the entire array, but if you want the intervals in which you want the elements in that subsets, then this step size will help. You will briefly understand this when we will see an example. Now it's time to look at the syntax of it. You can see that we need to first mention the variable name in which the array is stored, followed by the square brackets in which we need to enter the start index, end index, and then after that you can see with the colon operator we are separating the end index with the step size. So your start index defines the start of the subset that you want to retrieve. Your end index being exclusive will define that till where you want to retrieve the elements, and then the step size will determine the intervals in which you want the entire subset. Now let's take an example of this particular array. You can see that this is an array of 8 elements starting from index 0 ending at index 7. This particular array is of the type integer. Now let's say we need to slice this particular elements starting from index 1 ending at index 7. Note that 7 is exclusive over here, and then we have mentioned the step size as 2. So while slicing, the counter will first start with the leftmost element. It will check whether the current element's location is equal to the start index or not. In our case, it is not equal to the start index since our start index is 1, hence the counter will increment. Now the location of the current element is equal to the start index. Hence, it will retrieve the current element in the final result. So hence 54 is extracted as the first element in the subset. Now since we have mentioned the step size, it will check for the step size. So here the step size is 2. That means the counter has to jump 2 locations ahead, means 2 times. So therefore the counter will increment from 1 to 2 and then from 2 to 3. Whatever step size you give, the counter will increment that number of times. Now since the current element's location is not equal to the stop index, hence we can extract this as a part of the subset. So hence 51 is again a part of the result. Now the counter will increment 2 locations ahead, and again it will check whether the current element's location is equal to the stop index. Since they are not equal, hence it will extract. Now again the counter will try to move 2 steps ahead. Now note that after moving 2 steps ahead, since the current location is 5, after moving 2 steps ahead it will be at 7. But since the stop index is exclusive, hence the element till index 6 will only be retrieved. But because the step size is 2, the counter won't reach at index 6. Hence these are the 3 elements that are retrieved. Now let's have a look at the implementation of this. So here we have defined a simple array of integer elements with the help of the array library in Python. Then we have printed that ARR variable, and we can see that our array has got stored in it. Now let's perform the slicing using the step size. So for performing it, we need the variable name followed by the square brackets. In that we need to mention 3 things. First is the start index, then the stop index, and then the step size. All are separated with the help of a colon operator. So let's say the start index is this 76, which is at location 3. Now let's say the stop index is 8. The element that is located at this particular position is 3254. Note that the stop index being exclusive will not be a part of the array that we get into the result. We do not want this element 3254, hence we are writing this particular location inside the stop index. Next, let's define the step size. Here we have defined the step size as 2. Now the resultant array will contain the elements which are starting from this index 3. The element located at index 3 is 76. So hence 76 will be a part of the result. Now since the step size is 2, the counter will jump 2 elements ahead, and the element located at the current location is 45. Since 45's location, which is 5, is lesser than the stop index, hence 45 will be a part of the final array. Next again it will jump 2 steps ahead, and the current element is 10,000. The location of 10,000 is lesser than the stop index, hence 10,000 will be a part of the final array. Next again the counter will increment 2 steps ahead, and the element 545's location is greater than the stop index, and therefore the counter will stop here. And you can see that the 3 elements 76, 45 and 10,000 are a part of the final answer. So this is how the step argument works in the slicing of arrays. Now let's say the step size is 3. For this particular step size, it will jump 3 steps ahead, means 3 elements it will skip, and then it will retrieve the current element. So let's debug this, how we can get the result. Since our starting index is 3 and the element located at this particular index is 76, so 76 will be a part of final array. Next the counter will increment 3 steps ahead, and the element located at this particular step is 989, whose location is lesser than the stop index, hence this will be a part of the final array. Next it will increment 3 steps ahead, and the element 545's location, since this is greater than the stop index, hence this will not be a part of the final array. And after executing the cell, you can see that only 2 elements 76 and 989 are a part of the final answer. And this is how the step size in array slicing works. I hope you have got the logic behind this. If you face any difficulty regarding this, then post it in the comment section. Now we are going to see one more concept, which is negative indexing. In part 1, you might have observed glimpse of this. And you can see that we can retrieve the last element of any array with the help of the index -1. This negative indexing helps a lot when we are dealing with the elements which are located far away from the first position. Now, if we want to retrieve the elements starting from index -3 till index -1, then this is how it works. It will start from the -3, then since no step size is mentioned, then it will retrieve the element located at -2 index, and then since the stop index is exclusive, hence it will retrieve the two elements only. Now if we change the start index to -8, then it will retrieve the elements starting from index -8. So you can see that the element located at the -8 index is 76. So it will start retrieving the elements and the first element will be 76. It will stop at index -1. Now if we mention the step size as 4, then it will work normally as what we had in positive indexing. The only change is that here we are using a negative index. You can see that it will start from the element 76, it will jump to 4 steps ahead. The element located at this particular location is 10,000. It will retrieve this as a part of the final answer. Now again, if we move 4 steps ahead after 10,000, then we are not having a single element after this. So therefore the counter will stop and only these two elements 76 and 10,000 will be a part of the final answer. I hope the concept is getting more interesting. I have tried to take ample amount of examples for you to understand the positive step size. I hope all of these examples are clear and you don't have a single doubt. Now, moving ahead, we are going to see one more concept in this particular slicing, which is negative step index. Till now, we were dealing with negative indexing. Now, we will deal with negative step size. Now, the syntax for slicing remains the same for this concept. The only thing is, instead of positive step size, you will be having a negative step size. Note that the positive step size was incrementing the counter from left to right. In this negative step size, the counter will move from right to left, means the counter will decrement. Now let's define the step size as -2. Now since we have not defined the start and stop index, it will by default retrieve all the elements. Now we have initialized the step size as -2, hence it will retrieve all the alternate elements from right to left as a part of the answer. Now if we mention the start index as 9 and the end index as 2, note that whenever you are using the negative step size, then in that case your start index will always be greater than the stop index, since we are moving from right to left. So the element located at 9th position is 545. The counter will start from this element 545. Since the step size is -2, hence the counter will decrement 2 steps before and the element 10,000 will be printed as the answer. Now again the counter will decrement 2 steps before and the element located at this particular location is 45. It will again be a part of answer. Again the counter will decrement 2 steps before and the element, which is 76, its location is greater than the stop index. Hence it's possible for it to be a part of answer. Now again the counter will decrement 2 steps before and this time the current location is lesser than the stop index. Hence it won't retrieve further and it will stop. And you can see that the 4 elements are successfully retrieved. This is how the negative step size works. It works totally the reverse way of the positive step size. If you have any doubts regarding this, then you can post your queries in the comment section. Your doubts and suggestions are always welcome. I hope you like this video. Now it's time for you to perform this exercise. So here we have an array of 10 elements. Consider this particular array and answer the 2 questions that are followed by it. So the first question says that start from the index 3 and slice the array till the end with an increment of 3. So you need to start from the element 560 and then you need to slice entire array with an increment of 3 steps. So you need to post the answer of this in the format in which I have taught you, the correct representation. The second question says that reverse the entire array using the slicing concept. I feel that this is a very easy task. A hint is also given to you that you can use the concept of negative step size. Post your answers in the comment section. You can create an IPYNB file and upload that file in the GitHub, and you can paste the link of the GitHub in the comment section. Now we are done with the concept of slicing in Python arrays. If you enjoyed this video, then do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Thank you.